Today, we're going to take what we know about calculating percentages and apply it to some word problems. Let's get started. Question 1. The Serrano family went out to eat at Bonifacio's Cajun Eatery. If their bill was $68.40 and they gave their server a 15% tip, how much did they pay altogether? So in this one, we know we have a $68.40 bill, and we're going to be leaving some extra money. They're going to be leaving a tip, and we are asked to find the total amount that they're paying. And right now, we know they're paying a 15% tip, but we need to know what that is as a dollar amount. So we need to ask ourselves the question, what is 15% of their bill, or 15% of the $68.40? And we know how to do that. We're going to take 15% and we're going to turn it into a decimal. We're going to change the word of into multiplication, and well, 68.40 is already a number. And so we're good to go. We can either grab a calculator or a piece of paper and figure out the math here. And we multiply 68.40 times 0.15, we get 10.26. So that means they're going to leave a tip of 10.26. But wait, we're not done yet, because the question didn't ask us how much was the tip. This is the tip here. They asked us how much did they pay altogether. So now we need to take this dollar amount that we calculated for the tip and add it on to the bill. So we're going to take 68.40 and add it to the 10.26 tip. And altogether, they paid $78.66. Let's do the next one. Question 2. Mary is shopping for a jacket. She has picked out a jacket with a price of $144.60. Luckily, the jacket's on sale for 30% off. After the discount is applied, what will be the price of the jacket? So this one's a little bit different than the last one, because this time it's a discount, not a tip. So we're going to take that $144.66 price of a jacket, and we're going to subtract out the discount to figure out the final selling price. Well, to do that, we're going to have to figure out what the discount is. So we need to ask ourselves the question, what is 30% of the selling price of $144.60? $144.60. Let's get to work. Let's change our percentage into a decimal. Let's change the word of into times and bring down our 144.60. So our unknown is already isolated on this side of the equation, so we're ready to go. We can do the multiplication. 144.60 times 30% is $43.38. So we found out what the discount is. If the question had asked, what's the discount, then we'd be done now. But it didn't. The question this time is, what will be the price of the jacket? So we're taking our $144.60 jacket and we're subtracting out the discount that we have calculated. And our final price of our jacket is $101.22. Now, before we move on to the next question, I want to think about a different way we could have done this problem. Because we knew the original price of the jacket was $144.60. We calculated the discount and then we subtracted it. But another way to look at this problem is that if 30% is the discount, then that means at the end we're paying 70% of the original price. So what we could have done is asked ourselves the question, what is 70% of 144.60, and that would have given us the percentage of the price that we're actually paying. It would have saved us a step. Let's see if it works here. 70% I'm going to turn into a decimal of I'm going to turn into times, and now I'm going to grab a calculator and do the math. 144.60 times 0.7 gives us that same 101.22. So there you have it, a different way to calculate a discount. Question 3. Daryl went out to lunch with some friends. The group left a 20% tip of $7.68 on the bill. How much was the bill before the tip was added? Now you might be tempted here to figure out 20% of $7.68, but if we read the question carefully, we realize that is not what the question is asking. In this case, we weren't given the total for the bill. We have to figure it out. We have to work backwards and figure out what it is. So I'm going to think, well, if I did know what the bill is, I would have asked the question, what is 20% of the bill? These are the kind of questions we've done before. But this case, I know what it is. I know that 20% of the bill is $7.68 because they told me. So let's plug that in. So $7.68 is 20% of the bill. So let's translate this into an equation with a variable. 768 is equal to 20%, which I'm turning into a variable, times the bill. I'll just use a variable B for bill. So you can see in this problem, our unknown is on the same side of the equation with one of our knowns. So we can't just multiply to find the answer. We have to isolate our variable in this case. To isolate a variable, we do the opposite operation. So in this case, I'm going to divide this side of the equation by 0.2 to get my variable by itself. But whatever I do to one side of the equation, I have to do to the other. 768 divided by 0.2 is 38.40. So our original bill was 38.40. And if I were to go back and plug this in, I would end up with that 768 we were given. Let's try another one of these. Question 4. Sean bought a cell phone for 30% off the original price. His discount, or the amount he saved, was $142.50. What was the original price of the cell phone? So once again, we're not asked to find 30% of 142. We're asked to figure out 30% of some other number that gave us 142. In other words, we took the price of the cell phone and we calculated 30% of it, and that's what the discount amount was. So we were given the discount, we weren't given the original price, but we can figure it out. The price here is our unknown, so I'm going to use P for price, and we're going to multiply that times 30% as a decimal, and that is going to equal the discount. So once again, our unknown is not isolated, so we're going to have to isolate our variable to find the original price. And once again, we're going to do the opposite operation. The opposite of multiplying by 0.3 would be to divide by 0.3. So now we have isolated our variable, but whatever we do to one side of the equation, we need to do to the other. Now, we can grab paper and pencil, or we can grab a calculator. We grab a calculator. Just remember when you're plugging things in that we read math from the top down. So when we enter this into the calculator, we're going to put 142.50 divided by 3. And when we do that, we get $475 as the original price of the cell phone. And if we were to take that $475 and put it back here in our original equation, it'll work out. 30% of $475 is $142.50. Let's do the next problem. Nina purchases a photo album priced at $25. With sales tax, the total comes out to $26.75. What is the sales tax percentage? Once again, let's set this up like the easier problems that we've done. If we did know the sales tax percentage, we would have taken that $25 original price and we would have multiplied it by the percentage rate, and that would have told us the tax. But we weren't given the percentage. And really, we weren't given the tax, but we could figure it out, right? If the total was $26.75 and we subtract out the $25, that $1.75 that's left behind is our sales tax. So now let's set up our equation with the variable. We're going to take this 25 and we're multiplying it by the percentage, which in this case is our unknown. So let's use a variable. I'm going to use P for percentage. And that mystery percentage times $25 came out to $1.75. So once again, our unknown is not isolated. We have to isolate our variable here. And the opposite of multiplying by 25 is to divide by 25. So let's divide both sides of the equation by 25 to isolate our variable. Our variable becomes isolated on this side. And once again, we want to be careful when we put this into the calculator. We read from the top down, so we're entering this into the calculator as 1.75 divided by 25. And once we do the calculation, we get 0.07. Not done yet. It asked us for the percentage. We've got a decimal right now. So we're going to multiply this by 100 to get the percentage. So the shortcut is to move that decimal over 2 spaces, and our percentage ends up being 7%. And once again, we could take that and we could plug that back into our formula over here. We could plug in that 0.07 and we will end up with the $1.75. Let's do one more question. Question 6. A shopper wants to ensure he has enough cash to purchase an $80 coffee table, so he asks the clerk what the total will be with the sales tax included. The clerk tells him the total will be $84. What is the sales tax percentage? So once again, we're given the original amount, or asked to figure out what percentage we paid in sales tax. Now, before we can figure out the sales tax percentage, we need to know how much tax we paid. And we can tell that if we paid a total of $84, if we subtract out the coffee table, the $4 is left behind is our sales tax. So now our goal is to figure out what percentage of that total bill, what percentage of that $80 is that sales tax? Is that $4 that we paid? So let's turn this into an equation. What percentage? Well, that's what I don't know. I'm going to use P for percentage for my variable this time. Of becomes times, 80 is already a number, and $4 is already a number. And you'll notice here, for the first time here, I didn't change either one of these into a decimal. Because if you recall, we were changing the percentage into a decimal. And in this case, the percent is our unknown. But we're still going to solve it the same way, by isolating our variable. Opposite of multiplying by 80 would be to divide by 80. And whatever I do to one side of the equation, I do to the other. So our sales tax percentage can be calculated by doing 4 divided by 80. When we do 4 divided by 80, we get 0.05. Now, let's turn it into the percentage we're looking for by multiplying by 100. So our percentage is 5%. And if I really wanted to be sure, I could take that 5% and plug it into our original formula. That's our last question for today. I hope you found this helpful.